Hey guys, this is Unit 3, still 3.3. We are going to talk about how to solve systems of linear equations using substitution. So there are always going to be three methods that you have to be able to solve a system of equations. And what the previous videos have talked about are graphing, and what I'm going to show you today is this option 2, using substitution. So there are obviously times when either of these options make more sense than the other. It's important to review all three. We've already looked at graphing, so I want you to now see when it's appropriate to use substitution. So here's our three examples. Substitution is actually relatively simple, and we're going to show you in this first example. So if this was the problem, y equals 6 and x equals 2y plus 5, and you were given the directions to solve for x, I already see that y is isolated and y equals 6. So in order for me to solve for x is expressed in terms of y. So all I would have to do when it says how would you solve this is plug in values for y after y is isolated. So in this case, y already is isolated. So it's easy for me to say if y is 6, I can change this y to be a 6. And I can rewrite x equals 2 instead of y, 6 plus 5. And I just have to solve and multiply. 2 times 6 is 12, plus 5 is 17. So x equals 17. This is a really easy system, but you want to see this to figure out when you need to use substitution, when it's simple and isolated like so. So if you look at example 2, I notice that I have two equations again. Y equals 3x and x plus y equals negative 36. Again, if I look back to my how would I solve this, I can plug in my values for y because y is already isolated. So I already have y isolated by itself on the left side of the equation, y equals 3x. So now this y in the second equation can be changed to a 3x. So if I rewrite this, I have x plus y equals negative 36. But now instead of the y, I'm going to actually substitute that for 3x. So x plus 3x equals negative 36. And this is exactly what I want because now instead of having two variables, I only have all x's. I only have one variable, so I can actually solve. So x is like a 1x plus 3x is 4x equals negative 36. Divided by 4. X equals negative 9. The other portion of this is when you're solving an actual system of inequalities or equations, you want a solution. So it's not okay to just stop here where I have an answer for x. I also need an answer for y. What does the y equal? So when you go back up to how do you solve this, you need to make sure that you then, we'll label these, plug back in to find x. So in this case, we found our x. Now we need to plug that back in to find our y. Here is our x is negative 9. So if I go back to here, y equals 3x. Now I have what x equals. X is negative 9. So I can just plug negative 9 in here for the x. Y equals 3, negative 9. That's multiplying. So y equals negative 18. Now I'm done because I have an answer for both x and y. What I need to make sure I do is actually write my final answer in a point. So my x is negative 9 and my y is negative 18. So I have to write it as a point on a graph because really we're finding where they intersect or where they're equal to each other. So this is my final answer. Example 3 is more difficult because we're going to have to distribute. But this is also common, so you need to be prepared. Again, I already look at step 1 and I have y being isolated. I have one of the variables being isolated. So the only time I'm going to use substitution is when we have a variable isolated, like these 3 examples. I already know that y is the same thing as x minus 1. So I can plug this in for the y in the second equation. So I have my second equation is 4y equals 3x plus 3. Now, we have 2 variables right now, so instead of 2, we want to get down to only x's or only y's. What I'm going to do is I'm going to plug in this portion of the equation, x minus 1, for the y in this part of the equation, so that I swap out all my y's for x's. So now I'm going to have 4 still, times, and now instead of y, I'm writing x minus 1 equals 3x plus 3. Then I need to distribute this 4 to both insides of the parentheses to get 4x minus 4 equals 3x plus 3. Now I just need to solve for x, having all of my x's on one side. I can do this many ways. I'm just going to move 3x over to the other side. 4x take away 3x is 1x. Add 4. X equals 7. So again, I have my x answer now, but I need my y. I cannot stop until I have an ordered pair, just like this answer here. So I need to now go back, plug my x value in for either equation, either one of these 2 in example 3, to get my y. So I'm going to choose the easier one, that first one. Y is already isolated in this one. Y is equal to x minus 1. We already know x is now 7, which means y is equal to 6. Now I just need to make sure I put my answer in an ordered pair. X first, y second, and my answer is 7, 6. This is all for our examples for substitution to solve for systems of equations.